All right, so we are now on page number 45 of your notes. So let me see about getting my pen going on here. All right, so here I've got my pen, and we are on page 45 of your notes. And we are going to be talking about alkenes and alkynes. And again, whenever you're doing notes, you should always have your reference tables out. And specifically, we're still working with tables P and Q. Okay, so we have alkenes, which often are called the ethylene or the olefin series. And all the compounds in this series have names that end in ene, right? And the same prefixes as the alkanes, right? The prefixes come from table P, and then our endings come from table Q. So we have a carbon-carbon double bond, and then all the other carbon bonds are single. We say these are unsaturated. So on table Q, we have the alkanes, right? Those are the single bonds, are saturated. And so then our alkenes are unsaturated, right? Because there's less hydrogen, less full of hydrogen. And if you've ever heard of saturated or unsaturated in terms of fats, right, this is what we have the difference between an unsaturated fat and a saturated fat. So an unsaturated fat is a fat molecule, right? A lipid molecule containing a double bond. If it's polyunsaturated, that's going to mean there's more than one double bond. And if we have a saturated lipid, right, a saturated fat, that is going to have all single bonds, and it's going to have a lot more hydrogen, right? So here our double bonded unsaturated fats are going to be like our cooking oils, right? Our olive oil and coconut oil and stuff like that. And they tend to be liquids at room temperature because remember, the shape of the molecule is going to determine physical and chemical properties. And because of that double bond, that makes weaker intermolecular forces. So that means we're going to have lower melting points and lower boiling points. All right, so we can call these aliphatic. All right, so here I have the name. I have methene. Can't do that. I can't have a double bond with only one carbon. There's got to be two carbon bonds, right? Because remember, hydrogen can only make one bond. So there's no methene. So now we have our first one, ethene, which is the example they give you on table Q, right? So the prefix eth means two carbons with a double bond. Notice that carbon still has four bonds around it. 1, 2, 3, 4 for that carbon, and then 1, 2, 3, 4 for that carbon. And then don't worry about the angles here, but remember that these are all shared electron pairs, and they're going to arrange themselves in space to go as far away from each other as possible because like charges repel. So my condensed formula is going to look like this. I'm going to have a CH2 and a CH2. Okay, so then this is how I'm going to know that I do not have a alkane is by looking at that condensed formula. And then this is our molecular formula, which is C2H4. So this, according to table Q, right, matches the CnH2n. Okay, so that's our general formula, where N is the number of carbons. So for every carbon, there's twice the amount of hydrogen. I like looking for this one, right? 2 and 4 are double, so it matches this general formula. So now we have propene, right? So it matches our general formula, right? So 3, and then 3 times 2 is 6. And so here is our double bond right here. And now I have a CH3, and now I have a CH and a CH2, propene. And then now I have the next one, which is butene. Okay, so we are going to keep going. All right, so here we have butene. So I have 4 carbons. And now since there's 4 carbons, I can now draw this 1, 2, 3, 4. And so the double bond, right, CH2, and now I have a CH, and then a CH2, and then a CH3. So, right, this still matches our general formula, CnH2n, which is on table What table? Table Q. Okay, so we call this 1-butene. Well, why is it called 1-butene? This one is going to tell you, and there's that weird funny looking line I get sometimes with my touchscreen. You know me and this whole technology thing, guys. All right, so let's just erase, make this look a little bit cleaner. All right, so here we go. All right, so why is it called 1-butene? So this 1 indicates where the carbon double bond is located. Oh, make that look like a better double bond. Okay, so that's where the carbon double bond is located. It's after carbon number 1. So right between carbons 1 and 2. Counting from the shortest direction, just like we would do with a branched hydrocarbon. Sometimes you're going to see them, if you were to Google an answer, you'd see this funny little zigzagging thing. So, right, chemists, we like things like shorthand, right? Instead of drawing this big thing, we can do the condensed structure. We can even shrink it down even further like this. But then this molecular formula doesn't really tell you that much about the shape. But we can use this little zigzaggy thing to be describing the shape, where every point is a carbon. And then we know that carbon makes 4 bonds. And at the end of all of those extra bonds that I have to make those 4 bonds, those are going to be hydrogens, right? So I have a hydrogen here and here. So then I just need 1 more hydrogen there. And then this one only has 2 bonds. So I need 2 more carbon, 2 more hydrogens, and then 3. So the first number to touch the double bond is the lowest number. That's why we give it the 1, right? And then there we go. Okay, so now let's draw 2-butene with let's draw butene with the double bond in another location. So I am going to do this bond here. So now it's in the second location. So now instead of it being here, I'm going to move it here. So it's no longer after carbon number 1, it's after carbon number 2. So it's going to get a new name, 2-butene, because the number 2 indicates where is the double bond. Remember, if you can pick apart the name is going to tell you everything about the structure, and the structure is going to tell you all of the information about the name. You just have to use the logic and reasoning. You've got to be able to just kind of pick it apart. So now this is an isomer, right? This is a geometric isomer. 1-butene and 2-butene, they still have the same general formula, right? They're still C4H8, but you put them together differently. They have different physical and chemical properties because the shape of a compound determines physical and chemical properties. All right, so we already did that. So then this is an isomer. Remember, same molecular formula, which means I count however many all the elements there are, but a different structure and different properties. Geometric isomers because the multiple bond is in a separate location. So then now here's this general formula that I've been talking about. And we are not going to do all that because for the sake of time, we're just going to skip it. Okay, so I'm just going to go fast, right? We can move that double bond to all different locations. Okay, so now what we have is what we call a diene. So that's if there's 2 double bonds, right? So here I have diene, right? Ene means double bond. So if I have 2 double bonds, and I would never be asking you this, but again, if you just see this, somewhere like in the news, like some evil bad molecule as a diene, then you know what it is. So we're going to use the lowest combination of numbers. So if I have 1,3-butadiene, I'm picking this apart. So carbon number 1, carbon number 3, right? The numbers, there's nothing that ends with a YL, so there's no branches here. So then those numbers are indicating where are the double bonds. After carbon 1, after carbon 3. So then this is my prefix, but meaning 4. So then ENE meaning the double bond. So I have a 4-carbon chain and I have double bonds. I have 2 of them though, right? 2 of the double bonds. One comes after carbon number 1 and the other one comes after carbon number 3. So this is 1, 2, and that one goes there. So now I kind of have the skeleton. Now all I have to do is make sure that every carbon always has 4 bonds around it. So the first carbon over here only has 2 bonds, so it needs 2 more. And then those are hydrogens because these are hydrocarbons. This second carbon has 3 bonds, so it just needs 1 more bond. Could have drawn it on the bottom. It doesn't matter because this is a 2-dimensional rendition. And here's just, I'll put the next one there. And then now I just need 1 here and 1 here. So that's 1,3-butadiene. And of course, you already have this in your notes, right? Because it's already been filled in your notes, right? This is on page number 47 of your notes. All right, so now we're going on to page number 48. There's that. So why do I have this drawn like this? Because that's just showing the bond angles. So now we're going to go on to alkynes, and now we're going to get ourselves in all kinds of trouble. All right, I had to throw in one of my silly little, chemistry weirdness jokes in there just for fun, because I miss you guys in person. All right, so our alkynes end in Y and E, right? And still using the prefixes from table P, and our ending we get from table Q, right? So now we have the alkynes, and we have a triple bond, right? We go alkane, alkene, alkyne, right? So single, double, triple, it's right there on table Q. Triple bond, right, is going to be 2, 4, 6 electrons shared, or 3 pairs of electrons shared. And it's also unsaturated. So we have 2 that are unsaturated, right? We have the alkynes and we have the alkenes are unsaturated. The only ones that are saturated, full of hydrogens, are the alkanes, the single bonds. SS, single bonds are saturated. These are aliphatic. Don't worry about that. So we have ethylene. Maybe you've ever heard of. So not ethylene, ethine, or acetylene. Acetylene, if you've, somebody who's like, a welder, right? Usually they have an acetylene torch. The acetylene is the common name, and this ethine is its chemical name. So Eth means 2 carbons, right? And YNE means there's a triple bond between the 2 of them. So then and then remember H's at the end of those lines. Oh, maybe make it prettier H's. All right, so CH, right? So I have CH for my condensed formula. The molecular formula means I just count however many, right? I've got 2 carbons and I have 2 hydrogens. And so what's my general formula? Is going to be CnH2n minus 2, where n is the number of carbons. So if I have 2 carbons, right? 2 times 2 minus 2. 2 times 2 is 4, minus 2 is 2. Okay, so now let's look at propyne. So prop is 3, so I'm going to do 1, 2, 3. And then YNE means there's a triple bond. So I'm going to do the triple bond. So that's going to be the same thing as if I did that triple bond here. Because if I just flipped these back and forth, flipped them over, right? Like you flip a card over, right? That's where that double bond, it doesn't move position. It's still stuck the same way it's attached. But it just depends on which way you're looking at it. Are you looking at it from the front or looking at it from the back? And then every carbon gets 4 bonds around it. So then this one so then there's already 4 around that second one. And then I need 4 more here. So H, H, and H. So that's propyne. So I don't need a number in propyne to indicate where that bond is located because there's only one possible spot between the first and second carbons. Because remember, these 2 things are the same thing. And then here we have the same thing, right? So now I have a CH, and then I have a C, and then I have that CH3 for the condensed formula. And C3H4, does that match our CnH2n minus 2? Let's do a double check math. 3 times 2 is 6, minus 2 is 4. Yes, so it matches, and this is unsaturated. Right? Because it's not full of hydrogens. Look, there's like so much less hydrogens than there are in the alkanes. Okay, so let's draw geometric isomers of butane. Okay, so butane, but is 4. So I have got 4 carbons and I've got 6 hydrogens to place. So I'm going to show you how I draw this. So I have 1, 2, 3, 4. And so now The isomer just means that I am going to put the triple bond, oops, not double, triple bond, different places. Well, let's start here. I can put a triple bond there. So then I can do 1, 2, 3, 4. And now I can put the triple bond there. Can I put the triple bond on the other side, all the way on my right? No, because that's the same thing as the first one I drew. And then you have to make sure that every carbon gets 4 bonds around it, right? So then we would do all of those extra bonds. Okay? There we go. And then now you've already got these, right? And then we name them, right? This one came after the first carbon, right? So this is carbon number 1. So then this is 1-butyne, where the 1 tells you the location of the triple bond. Now this is 2-butyne, because it's going to tell you, the 2 tells you the location of the triple bond. And then the but means 4 from table P. Condensed structure. Okay, I want to know which one is unsaturated hydrocarbon. So unsaturated means not full. And either I'm having a double bond or a triple bond. So then this is not unsaturated. This one is saturated. Well, okay, I've got double bonds and all the rest. But this is where you have to be a super careful reader. This says hydrocarbon, which can only have hydrogen and carbon. So that's why it's choice number 3. This has oxygen. That's not a hydrocarbon. This has got 2 oxygens, not a hydrocarbon. All right, so we have a molecule of butane and a molecule of 2-butene. Both have the same total number of, well, if I have butane, so that's C4, and then it ends in ANE, so it matches 2N plus 2 from table Q. So 4 times 2 is 8, and then add 2, that's 10. And now I have butene, right? So that is C4, and it has to match the 2N because it's going to match the general formula that ends in ENE on table Q. This is H8. So now let's look at my choices. Do they have the same total number of carbons? Yes. Do they have the same number of hydrogens? No. Do they all have single bonds? Nope. Only ANE has the single bonds. ENE has a double bond. So they're there. So now, which general formula represents the homologous series? What is that? Notice that is the title of table Q. So why would I not use table Q if this in my question is part of the title? So I have 1-heptyne, YNE. So that matches the alkynes. So now I'm figuring out which one on table Q is a general formula that ends in YNE. Is that's going to be the 2N minus 2. All right, that is it for this set of notes. And I will see you next time. And we're going to talk about other organic compounds that contain other elements other than just carbon and hydrogen. So we're going to throw in some halogens and some oxygens and some nitrogens in there just for fun.